Hey everyone, Mr. Armitage here, and in this video we are going to be doing the Chapter 4.5 Homework Rational Root T, or Theorem, exercise 28, which is the last one, number 4. Right, so find all real solutions of x cubed plus 4x squared minus 11x minus 30 equals 0. Okay, and the real solutions are, and we have 3 blanks there. So we know we should have 3 solutions. Okay, first thing that we want to do is we are using, or starting off with, the rational root theorem. So we want the factors of our constant term. So the factors of 30, we have 1 and 30, right? 1 times 30, 2 and 15, 3 and 10. 4 doesn't go into 30 though, so that's okay, but 5 does, times 6. Okay, so we have those 8 possibilities. And then we need to look at our leading coefficient, which in this case is just 1. So factors of 1 well, there's just 1, right? 1 times 1. It's the same number. So fortunately, this works out very nicely. Okay, now all of our possible solutions to this polynomial are going to be of the form x equals plus or minus 1 of the factors of 30, our constant term, divided by 1 of the factors of our leading coefficient. And it continues like that. Okay, so we see that we have 8 possibilities here, right? There are 8 factors of 30 and only 1 factor of 1. So we will have 8 possibilities. 8 times 1. So there's 4 there. I'm just going down my list. Basically setting up the visual for it before I actually write it out. Okay, the denominator is always going to be 1 in this case, right? It may not be sometimes. And our numerator are the factors of 30. So we already did 1. We have 2, 3, 5. I just like to go around like that. 6, 10, 15, and 30. Okay. This means that all of our, well, once we simplify this, okay, we have all of our solutions look like plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 5, plus or minus 6, plus or minus 10, 15, and 30. Okay. So those are our 8 possible rational solutions to this. Now we need to test them. So let's just start with the first one. I'm going to set up my little synthetic division things side by side so I can do them one right after another. Here on the outside we have x equals positive 1. Here we have x equals negative 1. Or technically, that's the value of k. So I'm going to write k, because this is how we end up factoring it later. All right, now we need the coefficients for our polynomial, which are 1, 4, negative 11, negative 30. 1, 4, negative 11, negative 30. 1, 4, negative 11, negative 30. Right. And now we just go through the synthetic division. Okay. So bring down the 1. Positive 1 times positive 1 is 1. 4 plus 1 is 5. Positive 1 times positive 5 is positive 5. Negative 11 plus a positive 5 is negative 6. Positive 1 times negative 6 is negative 6. Negative 30 plus negative 6 is negative 36. All right, so this one is not 0. Okay. Our final, or evaluating this at the value of k equals positive 1, if this is not 0. So we know that this is not a root of our original polynomial. We're essentially evaluating our polynomial at each of these values and seeing if it equals 0. If it does, then that must be a root. So let's try the other side. Okay, bring down the 1. Negative 1 times negative 1, negative 1. 4 plus negative 1, negative 3. Negative 1 times negative 3, positive 3. Negative 11 plus positive 3, negative 8. Negative 1 times negative 8 is positive 8. And negative 30 plus a positive 8 is negative 22, which is also not 0. So, plus and minus 1, nope, doesn't work. Okay, we can cross that one off our list and go on to the next one. Okay. Now, why are we doing this? Okay. Why are we testing all of these? Well, quite simply, we don't really know how to start factoring this. Okay. In general, factoring cubic functions, which is this, right? It started with an x to the third power, can be really difficult if we don't have either a greatest common factor or some ability to group the polynomial and factor that way. Because usually that doesn't happen. So this allows us to test possible factors, and then we'll figure out what the rest of the factors are from there. So here we go, plus and minus 2. All right. Bring down the 1. 2 times 1 is 2. 4 plus 2 is 6. 2 times 6 is 12. Negative 11 plus 12 is 1. 1 times 2 is 2. Negative 30 plus 2, negative 28. Not 0. Oh well. Next one. Bring down the bring down the 1 for testing negative 2. Negative 2 times 1, negative 2. 4 plus negative 2 is negative 2. Negative 2 times negative 2 is 4, positive. Negative 11 plus 4 is going to be negative 7. And negative 2 times negative 7 is 14, which negative 30 plus 14 is negative 16. Also not 0, so that one's gone. All right, let's erase. And we'll start with 3 next. Okay, so we have positive 3 and negative 3. We only need one root to break this down into a binomial, a linear binomial, and a quadratic. And with the quadratic, we can factor that pretty easily. Bring down the 1. 3 times 1 is 3. 4 plus 3 is 7. 3 times 7 is 21, plus negative 11 plus 21 is 10. 10 times 3 is 30, and negative 30 plus 30 is 0. We got it. We got a factor. Okay? I'm not even going to test the other one. We have a factor here, or a possible solution here. Okay? So we can go back up here and say, real solutions are 0. There we go. There's one of them. We could try the other ones and see, but they should be in there. Okay, so let's go, or sorry, no. I got excited. The real solution's not 0. Right? I hope you called me out on that and were screaming at your monitor saying, no, 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 don't write that. The solution's not 0. It's just that when we evaluated the polynomial at this point, we got 0 at the end, which means that our solution is this positive 3. There we go. Positive 3. Cool. Now, we could test the rest of these, but I don't like to. You could, feel free, just test negative 3 and then test positive 5, negative 5, positive 6, negative 6, positive 10, negative 10, positive 15, negative 15, positive 30, negative 30, if you don't get all 3 solutions before then. Well, this is positive 3 here, so we can say that this root, or this factor, okay, the factor that matches this root is x minus 3. Okay, that's how we get the positive, times x squared, right? 1x squared plus 7x plus 10. And we'll just keep the equals 0 there. All right. Now, using our little X box factor method, okay, what 2 numbers when multiplied together would give us positive 10, and when added together would give us positive 7? Well, definitely positive 5. And positive 2. So I must have messed up when doing this. Interesting. Well, I hope you caught it and were also yelling at your monitor again for that, since I messed up. So let's go ahead and continue. So we have x minus 3 there. Now factored this, we'd have x plus 2 times x plus 5 equals 0. Right. And our zero product property states that we can take each of these terms, right? One of them can be 0 for the whole thing to be 0, so we can set them all equal to 0. X plus 2 equals 0. X plus 5 equals 0. So that's x equals negative 2, and x equals negative 5. So we can take those 2 values there, negative 2, negative 5. And those are our 3 real solutions. Okay. Now, if you're fine with that, You can stop the video here. I'm going to test -2 and see what I messed up on. Okay, so let's make this a -2. Bring down the 1. -2 times 1 is -2. 4 plus -2 is +2. -2 times +2 is -4. This must be where I messed up. -11 plus -4 is -15. -15 times -2 is +30, which is 0. There we go. That must have been where I messed up. -11 plus -4. See, I can make the same mistakes you do sometimes. Right? But we got it all figured out, right? We found a root that worked, we factored the rest, and it all worked out in the end. So our real solutions are x equals 3, x equals -2, and x equals -5.